Hello everyone, JCE Connect. I welcome you all for this particular lecture. In this particular lecture, I will be discussing about energy concept in open channel flow. So in previous lectures, we have been discussed about the most economical channel sections, and also we have solved some problems on most economical channel sections. So this particular lecture is mainly concentrating on energy concept in a open channel flow. How the energy can be calculating, that things we'll be discussing in this particular lecture. Let us consider one channel. It could be of any shape. Let us consider, and this represent the channel bed. Then, this represent the datum, that is a reference point. Then from the bed of the channel till the free water surface, this line represents the free water surface. Then that is written as y1. Then also draw energy line. This is energy, that is total energy line. Then according to Bernoulli, we know the energy can be written as the energy can be written as z1 plus y1 plus v1 square by 2g. Means whenever the fluid start flowing, it will be having a three kinds of energy, that is a potential energy, pressure energy, and kinetic energy. Potential energy will be because of its position it gains, pressure energy because of pressure in the fluid, and kinetic energy because of the motion it gains the kinetic energy. The sum of all will give you the total energy at a particular section. This is according to Bernoulli. This can be written according to Bernoulli. This is the energy. And at a section 2 again we can write the same. The energy at 2 will be potential energy, that is Z2, plus pressure energy Y2, plus kinetic energy, that is V2 square. This is V2 square. Okay, this is V2 square. Z2 plus Y2 plus V2 square. Then as we know, whenever the fluid is in motion, it experiences certain resistance. That resistance is because of the friction in the fluid, as well as the friction between the surface of the channel and the fluid. Hence the losses will be occurring. So along the direction of flow, the energy will get decreases because of the losses in the fluid. So that loss can be represented as HL. This is the loss, HL. Then the line joining the various points of energy, the line joining various points of energy, then that energy line or the slope of that energy will be calling as total energy line. Then the free water surface itself represents the hydraulic gradient line. Then this is the bed slope. Okay, so according to Bernoulli, we have written here the energy at 1, energy at 2 here. Then this represents the cross section of the channel. It could be of any shape, triangular, rectangular, trapezoid, any shape. It is having a depth of flow y and a small elemental thickness of dy, and this elemental area will be dA equal to t into dy. This top width is t, so it has been taken. Then according to Bernoulli, we can write the total energy of the flow at any section can be written as H equal to Z plus Y plus V square by 2G, and this total energy will be per unit weight of fluid. I hope you understood this one. This total energy at any section can be written. This is general formula, Z plus Y plus V square by 2G. At any section you can write per unit weight of fluid. Suppose this is the total energy what we are getting from this formula. Suppose if the datum head is not present, or if the datum head is coinciding with the channel bottom, if we are not taken this reference point, if the channel bottom itself, if you are taking as a reference point, then the energy can be measured from the bottom of the channel, that is this plus this, like this plus this, means this channel, that is the datum coinciding with the channel bed, then energy can be written as y1 plus v1 square by 2g. That particular energy is called as specific energy. So that is when the datum coincides with the channel bottom, then the total energy is called as specific energy, and that is given by E equal to y plus v square by 2g. That means the specific energy comprises of pressure head, that can be written as EP, plus kinetic head EK. So when the datum is not been considering as a reference point, if the datum coincides with the channel bed, then the energy is measuring with respect to the channel bottom, then that energy is called as specific energy. I hope you understand this one. When the datum coincides with the channel bottom, then the total energy is called as specific energy, which is given by E equal to y plus v square by 2g, that is pressure head plus kinetic head. Therefore specific energy E is defined as specific energy E is defined the the total energy of the flow per unit weight measured with respect to the channel bottom as a datum. I'll repeat. Therefore, specific energy E is defined as the total energy of the flow per unit weight measured with respect to the channel bottom as the datum. Or you can, other way you can define as the distance between the channel bed and the total energy line is a specific energy. The distance between the channel bed, and the total energy line. The distance between the channel bed and the total energy line represents the specific energy. So specific energy is also a total energy, but it is measuring with respect to the channel bottom. So here this datum is coinciding with this one. Okay, so that is called specific energy. Okay, I hope you understood this one. Specific energy. Specific energy is defined as what? Specific energy is defined as the total energy of the flow per unit weight measured with respect to the channel bottom as a datum. So according to Bernoulli, this is the equation what we use for the total energy. Specific energy is also a type of total energy, but we are measuring with respect to the channel bottom. So that is called as a specific energy. So next comes the specific energy can be uh, understand by having a drop and hump in a channel. That is drop and hump concept in a channel. So we can understand how the specific energy can be calculating if we have a drop in a channel, or if we come across any hump in a channel, how the specific energy can be calculated. So this is very very important to drop. Sometimes the question will be asked uh, in gate exam or any competitive exams. Suppose if you get a drop in a channel, what could be the specific energy at particular section? Or if you are come across with a hump, what is the specific energy of that a section? You have to calculate that energy. Okay, so let us take a channel. So this is the channel running, and suddenly it has got a drop. The channel bottom is being decreased here. This is the channel bottom. Suddenly it has got a drop here, then again it is continuing here. Okay, so this here, let us take this section 1, this section 1 and take this section 2 to here. So at section 1 we have a energy E1, and at section 2 we have energy E2. And this drop, let us represent this drop as a delta Z. This is the channel bottom. Then one can easily write the energy at 1. We know energy at 1 can easily, it can be written as y1 plus v1 square by 2g. That is specific energy. We are measuring with respect to the channel bottom. And E2 can be written as y2 plus v2 square by 2g. So this is the energy at 1 and energy at 2. So by looking at the figure, so one can easily write E1 plus delta Z is equal to E2. I hope you understood this one. E1 plus delta Z. Delta Z is the drop in a channel. Then E1 plus delta Z is nothing but E2. It means E2 is greater than It means what? E2 is greater than E1. Energy at section 2 is greater than energy at section 1. Because of presence of drop, the energy get increases at section 2 too. So the specific energy get increases. Okay. So E2 is greater than E1, hence E2 minus E1 will be delta Z. So what we can conclude here, if there is a drop in a channel along the direction of flow, then the specific energy increases. Look at, if there is a drop in a channel along the direction of flow, then the specific energy increases. So with this figure you can understand this one, where the specific energy is maximum. So if there is a drop in a channel along the direction of flow, then the specific energy increases. Then next one, take a hump in a channel. Suddenly if you get a hump in a channel, so let us take, this is the channel bottom or channel bed. This is channel bed. So this is channel bed. Suddenly if you are getting some hump like this, or some obstacles like this, if you are getting, so let us consider this again section 1, and this is section 2 here. Okay, and this is the height of the hump. So previous case we have considered drop, so here you consider hump. Consider this is hump. Okay, again one can easily write the energy at section 1, which can be written as y1 plus v1 square by 2g, and here one can written energy y2 plus v2 square by 2g. This is energy at section 1, this is energy at section 1, and this is energy at section 2. This is the hump. So here also we can write E1 will be E2 plus delta Z. Means E1 is greater than E2. Energy at section 1 is greater than energy at section 2. Then the delta Z will becomes E1 minus E2. And this will be the total energy line. So again, what is our conclusion here? Specific energy decreases if there is a hump in the channel along the direction of flow. So if we come across any hump in a channel, then the specific energy get decreases. Specific energy decreases if there is a hump in the channel along the direction of flow. So this is our conclusion. If there is a drop, the specific energy increases along the direction of flow. If there is a hump, the specific energy get decreases along the direction of flow. Then the total energy of a channel at a section will always decreases. So as I said, the total energy, if you are taking it, always decreases because it is depending upon the losses. If the losses keep on occurring along the direction of flow, the energy get decreases. Because we know as the water starts flowing, there will be a friction loss. There will be a friction loss. Because of the losses, the energy get decreased along the direction of flow. So that is given here. So the total energy of a channel at a section will always decreases in the direction of flow, but the specific energy may increase or decrease in the direction of flow. The total energy of a channel at a section will always decreases in the direction of flow, but the specific energy may increase or decrease in the direction of flow, because the specific energy depending upon the depth of flow. The depth of flow, suppose so the depth of flow suddenly decreases, then the energy get decreases. Okay, so like this, if you are getting any hump or a drop, the drop comes, the energy may increase at a section. If hump comes, again the energy may get decreases. So like that. So the total energy of a channel at a section will always decreases in the direction of flow, but the specific energy may increase or decrease in the direction of flow. This is the concept of hump and drop. Then next, suppose if we are having a channel that is for a horizontal frictionless surface. If we are having, suppose that this is a channel and horizontal frictionless surface, if there is no friction at all, as the fluid starts flowing, whatever energy we are having here at section 1 1, or if you take a section 2 2, section 3 3, so all energies will remain same. Energy at 1 is equal to energy at 2 equal to energy at 3, likewise energy at 4. Means this surface is a frictionless surface, there is no loss at all. So whatever energy we are getting at section 1 will be the same at 2, will be the same at 3. So that is given here for horizontal frictionless surface. The specific energy will remain constant along the direction of flow. For a horizontal frictionless surface, the specific energy will remain constant along the direction of flow. So this is the figure given here. Okay. Then this is about for a frictionless surface. And suppose if you are getting uh, like this, for a suppose if you are getting a channel like this. So this is the channel. You can try to understand the energy concept here. So this is the channel bed, and suddenly you come across a drop here. So let us consider this section 1 1 and this section 2 2. This is section 1 1 and section 2 2. Let us mark the depth of flow in a channel as a y1. Then since it is having a velocity at section 1, that is v1, here the velocity will be v2. Because of having a velocity, it will experience a velocity head here, that is v1 square by 2g. Again v2 here, then v2 square by 2g. When we mark energy line, so this point represents energy line, then along the direction of flow energy get decreases. Then again energy at 2 will be y2 plus v2 square by 2g, and this line represents total energy line TEL, and this is loss. HL is the loss due to friction, loss due to friction. Okay, then one can easily write delta Z plus E1 is equal to E2 plus HL. Then only you get the energy at 1 is equal to energy at 2. It is delta Z plus E1 is equal to E2 plus HL. Then E1 can be written as Y1 plus V1 square by 2G, and E2 can be written as Y2 plus V2 square by 2G. So this is specific energy at 1 and specific energy at 2. If these two energies to be equal, then delta Z plus E1 is equal to E2 plus HL. This is a concept of energy even in a hump and a drop. So again, the just you remember what is the specific energy. The specific energy is nothing but it's also total energy, but it is measuring with respect to the channel bottom. So this is very important concept in a channel flow. So in next lectures I'll be drawing the energy, that is a specific energy curve, how the specific energy curve can be drawn, and from that curve we can understand various things uh, that we'll discuss in the next class. So I hope you understood this one. So try to understand this specific energy. The specific, I'll repeat again, the specific energy is nothing but total energy only, but it is measuring with respect to the channel bottom. So that is y1 plus v1 square by 2g at a particular section. So I hope you understood this one. Thank you.